Good afternoon, all of you. We are very glad to welcome you all to the second session of the QEEE CII Industry Bridge series. Last week, in fact, we had the expert team from Saint-Gobain talking about innovations in glass industry. So today we have a totally different industry. We have an expert team from Bluestar and Mr. S. Kalyan, who is the Senior General Manager, Corporate Training and Development, is going to do the technical session today. And he's a seasoned veteran with more than 3 decades of industry experience in the field of refrigeration and air conditioning. He's basically a mechanical engineer, and he's also a master's in public administration. He has done thousands of training programs in this field. So that is the kind of seasoned experience he's having. And he's also a certified energy auditor. And for the HR session, we have Mr. Anto Kumar, who is the Deputy General Manager, Human Resources, Bluestar India Limited. And Mr. Kumar is an MA in Social Work from Madras School of Social Work, and he's also an alumni of Loyola College, Chennai. He's also a very seasoned expert in HR with more than 24 years of experience. So he will be talking about the HR issues in this particular industry and how, as an engineering student, you can prepare yourself to get a career in this industry. Then we also have a young engineer here, Mr. Karthik, who has been with the Bluestar for the past 3 years, so just transitioned from campus to an industry. So he's a young man who has become an engineer in the industry from being a student. So he can tell you and share his experience on how that trend happened from being an engineering student to an ace engineer in an industry. So we are going to have an exciting session for the next 2 hours with these 3 experts from Bluestar. And I leave the stage to Mr. Kalyan. And in the end, please have a good listening of this session. In the end, you can have a lot of questions, and our experts are here to answer any technical questions and HR related questions pertaining to this session. So have a great time. Thank you.
Welcome to all of you. It's indeed a great pleasure to talk to you. The topic as chosen for the day is energy conservation in the field of air conditioning. But before we go into that, are we competent to speak on this subject? Yeah. Yes, it is because Bluestar has been a leading organization working in this for the past more than 7 decades. We cool the essentials of life. Air, we are surrounded by that all over, all around us. We cool the food. We take ice creams, we take frozen foods, or vegetables, and various items which we consume today. They have to be kept if you want to have a longer shelf life. So we cool that. And of course, we cool water. The 3 essentials for life is air, food and water, and Bluestar is cooling all of them. We have done a lot of conditioning. Some of the prestigious projects of ours, we want to showcase them. Close to the Parliament House. Sure, all of you would have seen this many times on TV, maybe more times nowadays on the TV. We can all be proud that this particular building is Air Conditioning Bluestar Limited. Once the MPs, they vote for the bill goes for signing, it goes to the Rashtrapati, the President of India. That again, his place, Rashtrapati Bhavan, is again air conditioned by Bluestar Limited. Where does the PMO operate? PMO operates, Prime Minister's office, they operate from the South Block. That again is air conditioned by Bluestar Limited. Like this, around the country you find Bluestar is as air conditioned, quite a number of buildings, and both for the private and the public sector we have done. Now Air conditioning is basically, conditioning the air. To condition the air, the most important thing that we need to do is that we have to cool this air. What actually produces this cooling in an AC system? So many people will say so many things. It is the evaporating refrigerant which actually is producing the cooling in an AC system. The refrigerant is evaporating. For that, it requires heat. Absorbing the heat, it is going to evaporate. When it is absorbing the heat, when it is removing the heat from one location, that location, the evaporating refrigerant actually is producing the cooling in an AC system. Now, if we have this refrigerant in large quantities are very, large quantities like the Bay of Bengal or the Arabian Sea or Gangama, we call Ganges River, like that. If you have plenty of this refrigerant flowing all over the countryside, we can take a easy tap off from there and then give free air conditioning for all of you. But unfortunately, what happens is this refrigerant, which actually is man-made, is very costly to make. A. Second one, it is not available in abundant quantities. That being so, they had a responsibility. We have to recycle this refrigerant. This evaporated refrigerant has to be reprocessed. Then we have to bring it to a state so that it can be again evaporated. For this, what do? We make use of what we call a refrigeration cycle, which has got 4 components, of which I will be talking to you soon. This otherwise is also called the vapor compression system. The refrigerant which has got evaporated is compressed and then it is condensed. First it is compressed, then it is condensed, and then there is an expansion valve through which this particular refrigerant undergoes an expansion process. Then comes the evaporator. That is, the refrigerant which has got evaporated, here goes to the compressor. In the compressor, you find this getting compressed. The forward and the return stroke of this particular piston, similar to an reciprocating engine. The forward stroke actually compresses the refrigerant. On the return stroke, the refrigerant goes inside and fills the cylinder. Okay, so the compression takes place. The pressure and the temperature of this refrigerant increases. The condenser. At the condenser, as the name suggests, the refrigerant undergoes condensation. But this refrigerant which has undergone condensation, it is at high pressure and at high temperature. So we have to reduce this temperature but retain its liquid state. So what do? We send it through an expansion device. In this case, the expansion valve. When it goes through this expansion valve, the pressure comes down, so does the temperature. It is back to liquid form at low pressure and low temperature, ready to evaporate in the evaporator. So you find the temperature pressure characteristics marked there on the pipeline. You find here the discharge from the compressor, high pressure, high temperature vapor goes to the condenser, and then at high pressure and medium temperature, this particular, it becomes a liquid, and that comes to the expansion valve. From the expansion valve, it undergoes, rather at the expansion valve, it undergoes pressure liquid refrigerant, and because the pressure has come down, temperature also has come down. So it is ready to evaporate again. Since it is available, in the liquid form and at low temperature. So this actually is the refrigeration cycle. We also call this as vapor compression system, because the vapor is taken and compressed, and that is how we are processing this particular refrigerant. Now we go, if this is so, we have to use less amount of energy and get maximum cooling out of this. So Government of India came up with what we call a star rating. Okay, this star rating is basically given because the product's energy efficient. Star rating is an acknowledgement of the energy efficiency of the product. The less the energy it consumes, it gets a higher star rating. There are air conditioners with star rating from 1 to 5 stars. What I am going to do now is I am going to go to the board now and show you how these numbers are worked out. We come to an item called energy efficiency ratio. Okay, the ratio is nothing but the amount of heat that has been absorbed, okay, divided by the power that has been consumed. So if we have to put it in other terms, EER, which in this case is the energy efficiency ratio, is equal to cooling. What cooling produced divided by power input. Now both of this we are going to take it in watts. So let's try to work out one number, EER. We want to find out the cooling produced, let us say, is 3500 watts. This amount of cooling is produced. For this cooling to be produced, I am going to consume an power of 3500. The cooling produced is 3500. The power consumed is 3500. This energy efficiency ratio presently is 1. We want to improve the performance. Some research has been done, and then what happens? The power to produce the same amount of cooling now required is only 1750 watts. Now what happens to the EER? EER increases. It increases not from 1 to, it has gone to 2 now. The present EER is 2. Further research, the power consumed to same amount of cooling is 875 watts. What has happened to the EER? EER, earlier it was 2, now it has become 4. So EER actually is increasing as the input power comes down and the cooling is there. Cooling is there, but the incoming input power is low. So as the input power comes down, EER is increasing. We say that it is more energy efficient. We say we are consuming a lot of energy. Okay, so Government of India came up with a number saying that the higher the EER, we will give a higher star rating. So the star ratings are now available on the screen to you. Okay, this is a star rating which is available up to December 2015. The Government of India is also giving targets to all manufacturers like us. They keep on telling us, come on, improve like that. So the latest table here, this for the split air conditioners, okay, the star rating band, which is valid up to what? Up to 31st of December 2015. You find in this, if the EAR is 2.7, it is only 1 star. If the EAR is more than 3.5, then they give 5 star. This is as of the split air conditioner is concerned. Now the window air conditioner, since window air conditioner came in a little later, the star ratings are yet to catch up at higher levels. You find here the minimum EER, energy efficiency ratio, is 2.5 for achieving 1 star and 3.3 for 5 star. When you go to the marketplace, you will be buying an air conditioner, let us. You have a label like this coming on the machine. This, there are 4 stars, no, 1 star, 2 star, 3 star, 4 star. This product which carries this label is actually a 4-star product, and the manufacturer also gives the number here. The energy efficiency ratio of this is 2.9. He is already giving that there. Okay, so like this, you know, the star ratings are mentioned on the product itself. You see here various types of star rated products, range of air conditioners. We got window air conditioners available here. Okay, then we have got air conditioners, see, different colors, different ranges. Okay, we got 5 star, we got 3 star. You know, you find in the marketplace all these energy efficient products with proper labeling are available for the consumer. Now, energy efficiency is paramount. Everybody is conscious of the energy consumption. So how do we better this? So the next line of products came, which we call them as the inverter driven machines, inverter compressors we call them. Okay, this is used in split air conditioners, so we say that inverter splits. Since the inverter compressor is used in the split air conditioner, we say this particular machine is an inverter split. Okay, now you see here what happens. This inverter is varying the frequency, thereby PM of the compressor. Suppose at home you have got a fan, you are keeping at speed 1 at home, the fan, it will be running at a slow speed. I am sure all of you will understand what I am saying, correct? No? If you keep it at speed number 2, it gives more air, it is running at a higher speed. You keep it at 5, then you find a lot of air gushing on you, because the fan is running at a very high speed. Okay, so by increasing the speed, we are able to get better output. Extending the same logic, what we have brought out is an inverter compressor built in an AC system. This inverter compressor runs at lower frequency when demand is low. When more cooling is required, what will happen? It will choose a higher frequency and it will deliver higher capacity. Now, low capacity requirement, low capacity demand, so low cooling given. High capacity requirement, you want more capacity out of the machine, it will spin at higher RPM and give you higher capacity. That is the advantage of this inverter system. But there is one more big advantage when we use the inverter system. What is that advantage? That advantage is nicely shown here in this bottom sketch here. The picture at the bottom shows you this. There are 2 categories here. This is the normal air conditioner, which we call as the fixed speed compressor fitted air conditioner. This one is an inverter compressor fitted air conditioner. You see here, normal compressor fitted, constant speed fitted compressor fitted into this air conditioner. Temperature swing is so high. That means the guy gets uncomfortable, and because it becomes too warm, and so he gets angry, not cool enough, and sometimes it becomes too cool for him. He starts shivering. Okay, But then the moment you switch over to the inverter compressor fitted air conditioners, it is constantly evaluating what is the demand that is required. Meeting the demand will be the top target of this particular inverter driven system. So the variations are very minimal, and you find here, you always are comfortable. That is the advantage of this inverter machines. Now these inverter driven machines are good for small systems. We go to the next one, what we call a VRF system, variable refrigerant flow system. This is the latest technology available in the world, and it will be pertinent for all of you to learn this in this next about few minutes, which I'm going to speak to you people on this. We all know, as I had told you a couple of slides before, the evaporating refrigerant is actually producing cooling. What quantum of this refrigerant has to be evaporated to produce the cooling? We can take it approximately 1 kilogram I have to evaporate to produce 1 ton of cooling. We call it mass flow rate. So rate, when we say, we have to give a unit of time. So if we have to produce cooling of 1 ton, G of the refrigerant minute. Suppose I have got 5 tons, then I have to evaporate 5 kg of the refrigerant per minute. If I have 100 tons requirement, then I have to evaporate 100 kg of the refrigerant. Okay. Now I have to vary the refrigerant flow to match the demand of the system, and so is born this VRF. We are varying the flow of the refrigerant. Because we are varying the flow of refrigerant, this is simply called VRF, variable refrigerant flow system. Now because we are looking at the demand and then supplying the quantum of refrigerant that occurred, okay, we will end up in a very energy efficient system. You see the various advantages of the VRF system. It is first on the top, it is a very energy efficient system. Second, it gives you capacity control. What? It is giving you precise capacity control. It gives you, it helps you to get better diversity. It gives you multi-zone control. It can also connect you to a building management system, ease of installation. There are many advantages like this. This VRF system comes to us in 2 technologies. First technology is the inverter VRF, inverter compressor fitted variable refrigerant flow system. The second one is the digital scroll technology. This digital scroll compressor is fitted in the VRF system, and so this is called digital VRF, because we are using a digital scroll compressor and it is fitted into a VRF system. This particular technology is called digital VRF system. So actually we have got 2 technologies. I would like to showcase both these technologies to you young people in this particular forum. First is the digital scroll, easy to understand, so we are taking up this first. So what happens in this is that this compressor is a typical scroll compressor. This scroll compressor has got 2 scrolls. The moment somebody says a scroll, okay, it something looks like this. You find here there are 2 scrolls there. One scroll which is stationary, another scroll which is orbiting. Okay, there are 2 scrolls. This is almost similar to this tortoise mosquito repellent coil we all use at home. Okay. So one of the scroll is stationary, which you find there, and the other one is an orbiting scroll. This orbiting scroll is not rotating, it is just orbiting. Please remember, this orbiting scroll actually picks up the refrigerant and slowly compresses that, and then out from the middle comes the compressed refrigerant. Okay, that's how this works. Now these scrolls are actually mated like this. The stationary scroll is on the top, and the bottom you got one more scroll, which is the orbiting scroll. It is not rotating, but it is orbiting. Okay, when this orbiting scroll is taken out, once they are together, it is producing some thermodynamic useful result, thermodynamic output in terms of compressing the gas. Suppose if the two scrolls are away, it will not be in a position to do the compression. Okay. So this particular compressor incorporates a novel way of disengaging these two scrolls. So we come to that here. This is that particular compressor, that digital scroll compressor. It has got a solenoid on the top. This particular solenoid, okay, if it is on, this is closed. Okay, so you find both the scrolls, the orbiting scroll which is in blue and the stationary scroll which is in green, they are both touching one another. No, this time we say this is loaded. Whereas when it comes to this, now here this particular, you find here this is engaged, sorry, this is engaged, whereas this is not. This is disengaged. This position we call as unloaded compressor. So you find here fully loaded and this as unloaded. Now we go to the next one. By time averaging, the time this is going to be together and this is going to be away, we will be in a position to get differentiated capacity out of this compressor. Okay, so you find here these two the scrolls, the bottom orbiting scroll and the stationary scroll, they are loaded together for 16 seconds. Actually we take 20-second cycle, 16 seconds these are together, and these two scrolls are not touching one another for approximately 4 seconds. That means out of a 20-second cycle, 16 seconds it is loaded, the compressor is giving you cooling or giving you the compression. For 4 seconds it is not giving you cooling. So that comes actually 80% capacity. So we say 80% of the capacity is delivered out of this compressor. So this actually is the digital scroll compressor technology. Okay, the second one is inverter. What is an inverter? Inverter basically is you have AC power supply, we take it through an inverter arrangement. First we convert the AC to DC. So this is as available as a DC supply. Now this DC is taken to a, first is a, here is a rectifier, then there is an inverter. In the rectifier AC is converted to DC, and then here this DC which is supplied is converted into similar to AC, quite logically as close to AC as possible. That is fed into the machine in a varying frequency. I would like to show a small animation now. See, we find here this we call as the switch. Changing the speed of switching, we are able to get a differentiated RPM of this particular rotor. Here let us say this is actually the speed of the compressor. Presently what is happening, compressor is running at a slow speed. Now if I have a higher demand and I want more cooling, then what will happen, the switching speed will slowly increase. That means what, the power supply is going like this, you see this red signal, then it comes, then the green, red is the power in, green is the power out, you can consider that way. As the switching speed, now the switching speed is increasing, are you able to observe that? As the switching speed is increasing, the compressor speed is also increasing. By varying the frequency, I will be in a position to deliver a differentiated capacity. That is the advantage of the technology. So we have seen both the technologies. First technology was digital scroll compressor fitted digital VRF, and then the second one was the inverter compressor fitted VRF system, inverter VRF, both the technology we have seen. Now we come to large buildings. When you have large buildings, in a building, which is the one which is consuming more amount of electrical energy, invariably all of you will vote, I am sure, it will be the which is consuming the maximum amount of power. Lighting and all is nothing, you know, some 14% only. Electronics, all of you use computers, no, see, that is the problem. It is also consuming so much of energy. Nobody can beat us, huh? We air conditioning people only consume maximum energy. Nobody, we got a responsibility. We have to help you people save your hard earned money. So they have brought in a lot of technologies to save money for all of you. Okay. So when we take up building design, we bring in lot of ideas to reduce the energy consumption in a building. So we advise people that the orientation of the building should be so selected that facing east and west, you see the way it is shown here, prefer north and south direction. That means what? We don't want sun to come directly into the building. But this is east and this side is west. You see in the building, both the eastern side and the western side, sun is coming and hitting the wall. Suppose if the sun is coming and hitting the glass, daytime eastern direction sun is coming and hitting, and afternoon western sun is coming and hitting, the load in the building will be very high. So we are advising that all of you people should be smart in choosing the orientation in such a manner that you choose north-south orientation. Okay. Then we will come to the next one. Avoid, if you reduce the gas, that much could be and save. Lot of energy you will save. But what is the problem today? No building is without glass. So we are suggesting that when you have no choice but to go for glazing, okay, you have to go for double glazed walls. If it is a smaller area like your homes or smaller offices, you know, through the entrances and all, you can have awnings. We all remember in those days when we had windows, we had what we call a sunshade. What is the object of that? To shade the sun during that 2 to 3, 4 o'clock time, because when the sun comes inside, you will know he is there. Okay, it will be pretty hot. Okay, so the awning is recommended so that it can calm that much. And then see here another one, what we are showing here. When you have no choice but to have windows on those sun exposed walls, you need to go for curtains or blinds such that the heat ingression to the building is substantially reduced. We call them also as shading devices. shading devices. Okay. Then another one, invariably all our buildings today will have roof, no? This roof is exposed to sun all the hours of the day. Whenever sun is there, whether you get light and heat from your windows or the walls, the sun is always giving the heat onto the roof. This heat which is coming from the terrace or the roof is coming into the building, especially the top floor of the building, and it becomes very warm. So it has been found when we do underdeck insulation like what we have shown here. If you do underdeck, this dark black color underlining which has been done here, this has been done here. Okay, that has actually been done under the deck. That means what? There is a slab under the deck. I have done insulation. That is what is called underdeck insulation. This is done inside the building, so it is not exposed to the vagaries of the weather. Very safe. Once for it's done, for lifetime of the building, this insulation is going to save you on your electricity bill. You will save quite a lot of money on this. Then another thing, dark colors absorb heat, light colors throw away heat. So whenever you are, when you are as an architect, as an engineer, you want to take a call on the type of coloring that should come on your building, choose colors which are bright light. Then comes you got your air conditioned space is there. This air conditioned space, if it is exposed, then probably a lot of heat is going to come in. Is it possible to keep a little recessed inside? Look at this option. You can use this for carriageway, toilets, and elevators and stores. All those things. Utility rooms, elevators. You decide the way you want to keep, but keep the air conditioned space substantially covered in such a manner that you will not, you don't need to run it for longer hours, spending a lot of energy. Okay, when you have large buildings, you have no choice but to go for this. Okay, when you have a tower, say about 10-story building, 20-story building and things like that, you can't send the refrigerant. We all know refrigerant which is evaporating, the evaporating refrigerant is actually producing cooling. You cannot send the refrigerant to all corners of the building because it will be very expensive. At the same time, before the refrigerant reaches that end, it would have got evaporated. So where is the cooling going to be produced in the end of the building? So it's going to be a problem. For that purpose, what we do is we cool some other item and send that item, some other fluid, and that fluid across the building to various parts of the building. Okay, so the other one which is sent is nothing but water. Since this water is cooled and is transported in chilled water pipes, I'm going to say what is that word chilled very soon, just please wait, to various parts of the building. This water is a special water. We all know water. Hot water will be in the range of about 50 to 55 degrees Celsius. We know ice water. Ice water, you have water to put couple of cubes in that glass of water, then you get very cold temperature water, almost as cold as the ice. So that is called ice water. It will be very close to 0 degrees Celsius. Okay. So we go to the storage water cooler and you take some water. That water which is taken out of the storage water cooler, the temperature of that will be 15 degrees Celsius. So the normal water is 30 degrees, hot water probably 45 degrees C and above. Okay, we come to the one ice water probably in the range of 0 degrees Celsius. There is normal water, there is ice water. You go to the storage water cooler. In the storage water cooler, you get water which is in the range of approximately 15 degrees Celsius. This 15 degrees Celsius water is called cold water. If you drink this cold water, you will not catch cold. Don't worry, you can drink as much as you want from a storage water cooler. Now, but this is not what we require for air conditioning buildings. So we go to a temperature which is middle of this, which is approximately 0.2 degrees Celsius. This water, we call this as chilled water. This chilled water is actually produced in a chiller. Okay. The equipments that are required to chill this water are called chillers. On the screen you find two types of chillers. One is an air cooled chiller and another one is a water cooled chiller. The job of these giant ones is to chill water, and this water which has been chilled, okay, is circulated across the building. You see here, this the refrigerant which is fitted inside this particular chiller is refrigerant R134A. This is a green refrigerant, and so these are also called green chillers. Basically energy efficient, so we call these chillers as energy efficient green chillers. Okay. Here we have got a typical water cooled chilled water system shown to you on the screen. You have the since it is a water cooled chilled water system, you got a cooling tower and associated pump which we call as the condenser water pump is also kept there. This is the refrigeration cycle here, comprising of compressor, condenser, expansion device, and here chiller is there, which also can be called as a cooler. So these four together, they are actually the refrigeration cycle. The cooling tower, the condenser pump, and the condenser, this particular thing, water piping system. Now the water which is chilled here in the chiller is circulated to what we call an air handling unit. This air handling unit actually is cooling the AC space. Okay. Now this AHU, which otherwise is also called the air handling unit supplies the air, cold air, into the AC space, making all of you comfortable. Okay. So the air which is circulating is actually picking up the heat, the heat which is picked up by the air from the AC space is transferred. The chilled water transfers the heat to the refrigeration system. The heat is transferred to the condenser water system. From the condenser water system, rather at the condenser water system, the heat is thrown away. You see here, the heat comes inside in the AC space, then the heat is thrown away here. To make these people feel comfortable, so many systems are working. We should be very clear in this. So when we have this type of an arrangement, we have to do the pumping. We have to do the pumping of the chilled water in a correct manner. We have to do it in a very energy efficient manner. So how are we doing? What are the new technologies which has come inside, which we are using to make all of you save a lot of money? So first, the various types of pumping arrangements we call them different pumping systems. There are three types here. Primary pumping arrangement, that is number one, which has been, people have been using this for more than 4-5 decades, pretty old system. Then the new concept came, which was codenamed as primary secondary pumping arrangement. Today we are talking about this variable pumping arrangement using a primary pump, variable primary pumping. So these are the three technologies which are there. So we will see each one of them now. Primary chilled water flow diagram. Okay, in this arrangement what happens? We all know, instead of sending the refrigerant, we are sending chilled water. It is flowing across the cooler or the chiller and also the air handling units. It is being pumped by these pumps through the chiller and then it is sent to the air handling unit. Chilled water is taken by these chilled water pumps, sent through these chillers, and then the water is circulated. What happens? As the water is flowing through the cooler in this chiller, the temperature falls down. It falls to as low as 7 degrees Celsius. So this 7 degrees Celsius, all remember, is the one which we showed here. We all showed here, 7.2 degrees Celsius, you all remember, no? I wrote on the screen that time. That 7 degrees Celsius water will come out of this. That water is going into the air handling unit. As it enters the air handling unit, it picks up heat but cools the air in the AC space. Because the air has become cool, the heat from the air has got transferred into this chilled water. Water which entered that particular AHU at 7 now comes out at 12 degrees Celsius. 12 degrees Celsius water comes to the pump. Pumps this water to the chiller. Water in the chiller drops down in temperature from 12 degrees to 7 degrees. So this cycle is continuously repeated. So in the primary chilled water flow arrangement, these pumps are circulating water. We can also call them as primary pumps. These primary pumps are circulating the water through the chiller and through the AHU, and these are the pumps which are doing the work. Okay. Now the load in the building keeps varying. As the load in the building keeps varying, we look for an opportunity. Can we do some amount of saving in pumping costs, because the pumps keep running? Let's say each one of them is 50 kilowatt pump, and 50 if it's going to run 1 hour and if it's a 50 kilowatt pump, it's going to consume 50 units of electricity. It's huge, and then there are 4 pumps, pretty expensive to run them, right? Okay, so how are we to reduce the pumping costs? So came up another alternative, which we are classifying that primary secondary pumping arrangement. In this primary secondary pumping arrangement, we got one set of which we call as the primary pumps, which are circulating water only to the chiller. There is another set of pumps which are supplying water to the air handling units and fan coil units. This primary pump is designed to supply constant water flow across the chillers, because the chillers are designed to take a specified quantity of water minimum. Okay. Now we come to the secondary pump. The secondary pump has to supply water to the AHUs and the fan coil units and all that stuff, okay, which are actually part of the load. And as the load in this varies, in the building varies, the quantum of water to be pumped to this will vary. So we look at an option, can we run this pump at lower speeds, thereby save electricity. Now quickly let us understand what happens here. The power consumption can be explained by using this affinity law. What is this? Flow is directly proportional to speed. As I increase the speed, as I increase the speed of the pump, I can get higher flow. As I reduce the speed, I can get reduced flow. Okay. Now, when I change the speed, the pressure coming out of the pump varies by the square of the speed, and when I varies the speed, the power varies by the cube. Okay, let me explain you with a small formula. First is RPM. Let's say it is running at 1000 RPM and it is pumping flow rate, that's in US gallons. Is pumping 100 US gallons and it is consuming the head, it is giving 100 feet head, and power, let's say it is consuming from our point of view 10 HP. Okay, that's all in this units. It is running at 1000 RPM, it is giving you a flow rate of 100, the head developed is 100 feet head, and power consumed is 10 HP. Now what I am going to do, I am going to reduce the speed of this pump. I am going to run this at 500 RPM now. I am reducing the speed by half, right? What happens here? The flow rate will become half of this. The flow rate will become half. That means the flow rate will be 50. What will happen to the head? Head will be proportional to the square of the RPM. So 100 into 1 by 4, that becomes 25 feet will be the new head when I am running at 500 RPM. When I am running at 500 RPM, what will happen to the power consumed? Power consumed will be the cube of this. Okay. So 10 divided by 8 will be how much? 1.25 HP. So when I am going to reduce the RPM, I am going to get a huge power saving. What is the amount of power saving here? The power saving is 87% saving is happening. You should remember. So it is very important that whenever the load is coming down, we have to put all our effort and reduce the power that is being consumed. Okay, this affinity laws are very useful, and we have found that it's a remarkable law for us in terms of saving huge amount of electricity. Today we can proudly say substantial percentage of energy has been saved on this because of this. Okay, the next technology which we are talking about is the variable primary flow system. So in the primary secondary system there were two sets of pumps. Okay, here what is happening? We are using only one set of pumps, but we are ensuring that all of them are fitted with variable speed drive. Because they are all fitted with variable speed drive, these chillers give you the correct capacity meeting the demand in the across the various loads. Then we also get the energy saving in pumping costs. So that is the advantage of the variable primary flow system. So coming to energy efficient air conditioning system design, what happens in a daily as a daily load, if we are taken specifically the month of May now, around 4 p.m. this becomes high. So you also find in this the load is not same throughout the day. Morning, early morning 12 o'clock you see it's very low and it peaks at 4 p.m. and again around 12 a.m. it's coming down. Okay, so you find the load is varying all the time. See in November the load is not that high. In the month of May the load was high. Here in for a particular typically building we say around 1000 tons we are considering in a particular building. Now here the load in November has actually fallen down to close to 2/3 of that. So winter, summer and all you find the capacity of the capacity to cool in a building is coming down during the winter months. So we also have to look at the building actually is not going to be in full load all the time. So the concept is by what we call part loading of buildings. So people are all saying, hey, don't design buildings with peak efficiencies during peak load. You have to always ensure that you give peak efficiencies at part load. That is the talk of the technologies today. So you find that all the AC system designs, they have to match up to the latest research findings of HRI. It goes like this. They say the latest research findings say that the peak load in a building is there only for 1% of the time, and the building is 75% only for 42% of the time. 75% load only 42% of the time, and 50% load for 40% of the time. Suppose the building is there which is 1000 ton in a building. In the building will be having 500 ton of requirement for 45% of the time, and 750 tons it will be requiring for 42% of the time. 1000 tons which is the peak capacity, it will be requiring only for 1% of the time. So if you are going to design the chillers etc. for 100% peak load efficiency, then it will be a great misfit in an energy conservation environment. So we need to look at opportunity to save during part load operation. So we came with the HRI, they came up with a nice acronym called IPLV, integrated part load value. Okay, this integrated part load value, this is the formula for that. Okay, they say A, which is the kW per ton for 100% of the load, B 70% of the load, C 50% of the load, D 25% of the load. All this is here, and they are all summed up, and reverse of that they have taken as IPLV, and this IPLV is the one today which are compared. We come to the main equipments now. We got in a building we will have chillers, cooling towers, AHUs, chilled water pumps, condenser water pumps like this. Chillers consume quite a lot of this energy. Out of the AC system which is consuming 55% of the energy, chillers consume the maximum. So what we should do? We should give the chillers fitted with the best of the energy efficient compressors. So how do we make the efficiency better? So first we bring here the old technology which was actually consuming lot of energy, which we call as the reciprocating type compressor fitted in a chiller. Okay, then slowly people said no, it is not giving us the required energy efficiency, so we will go for the next technology. They came up with rolling piston type, we call as the rotary compressors. Then came the next technology scroll compressors. You remember I was telling you about this stationary scroll, orbiting scroll, and the gas, blue gas is entering here. You find the compressed gas is coming out of this. So you find in in this better energy efficiency happening, and see you find on the screen now a screw compressor working, giving you a the compression process, how it is taking place. Initially it is blue gas, cool gas. As it comes out, it is red in color. Okay, that means the compressor is doing a job of compressing that refrigerant. And then this is the fifth variety, which we call as a centrifugal compressor. Okay, these 5 types of compressors, they have been perfected to give you the best of the energy efficiencies. Okay, but then at this point I want to tell you about the type of a chiller which gives you the best IPLV value. Okay, that is this magnetic driven, magnetic direct drive system. Okay, which is used in this particular compressor. Okay, this compressor is actually, as you find these impellers, these impellers basically are centrifugal impellers. Okay, so this compressor is a centrifugal compressor. This shaft is made out of a magnet. Okay, this is a permanent magnet. This magnetic shaft is suspended in a magnetic field. We all know if it is a, if it is south pole or north pole, you find them, coming together. Suppose if I have south pole and this also is south pole, what will happen to this equipment now? It gets suspended, right? This is south pole, this is also south pole, then it gets suspended. So by using the same technology, what we have done here is we have achieved a complete flotation of this shaft, and since the shaft is not touching any member, any bearing, etc., you get zero friction when the shaft is rotating. The shaft is rotating in a magnetic field, not touch any material body at all. Because of that, we are able to spin this shaft as close to as 48,000 RPM, giving you a very high energy efficiency. See, you find here, this is the shaft. This is completely a magnet. It's a permanent magnet shaft colors, and these are the bearings which are there. These are all magnetic bearings. Okay, and since it is permanently magnetized, it stays for quite a long time. 15-20 years, you will have no problem. The energy efficiencies are close to 97% and things like that. Okay. Okay. Now the next one which is going to consume, okay, higher amount of energy is your air handling unit. Okay. I'll make it not dancing. The image is now stable, so I'm making the image stable. Okay. Okay. Now you find here the job of the air handling unit is to clean the air. So because of that, we have the filtration, heating or cooling cycle or the coils which are there, and then there's the cold air is thrown here. The return air is collected, fresh with added with fresh air, mixed up with fresh air. Both of them are taken, and then after making it cool, you are putting it in the AC area. Okay, that's what is happening there. Now, how are we to get energy efficiency out of this? Okay, these HUs are always pumping air. Okay, if I am able to change the airflow of this HU, I can bring in some energy saving, right? And that's what actually is planned now. We incorporate what we call VAVs, variable air volume. These HUs also are variable airflow. HUs are also coming. Now, when it comes like that, it is fitted with what we call a variable speed motor in this, once it is fitted with a variable speed motor, variable speed drive, we call it the VSDs also, and it is fitted with a VSD, you get enormous amount of energy saving. And when the load comes down, the quantum of air to be thrown into the space comes down, and thereby you will be in a position to save energy. We have already spoken about pumps, so we have covered chillers or the compressors we have covered, we have talked about HUs, we have talked about pumps already. Now we come to ducting. In ducting, can we do some saving? Indeed yes, you can do saving, because ducts are the passages through which the air is staying or flowing. If you have no leakage, then you can straight away get a good amount of saving. For that purpose we all go for factory fabricated air ducting systems. You find in this arrangement on the screen now, these are two places which are offices, this is a laboratory. Okay, I will bring all the numbers before. Okay, now see what is happening. This is our air handling unit. This air handling unit is supplying cold air to the two offices and also to the laboratory. I am sure all of you are able to visualize this, no? After cooling the room, you find this dust laden air is coming back to the air handling unit. At the same time, part of it is also exhausted, so that we can add some amount of fresh air. The fresh air along with the recirculated air is filtered, cleaned. Okay, so these two areas are constantly fed with fresh air. Now let us see what happens in the laboratory. In the laboratory, there are a lot of fumes which are created and that need to be exhausted out. Okay, that exhaust is happening. Okay, and we are not supposed to take any return from the laboratory. No return from the laboratory. Because of that, we are also exhausting. So you find whatever the cold air is coming, the cold air picks up the dust particles and all that which are to be removed out of the space and is exhausted out. Okay, that is happening here. Now, if I am going to do this, I am also going to waste a lot of cold air. No, is it possible for me to recover some of the chillness? We will see after some time. We have to do some on cooling which is already there. We should not lose them unnecessarily. So we have got what we call heat recovery wheel. We got heat recovery wheel, and the heat recovery wheel, what does it do? It actually picks up the chillness and it retains the chillness, and it gives it back to the room. Let us see how. Okay. Okay, here is an image of a heat recovery air handling unit. Okay, here you find the return air, cold air will come, isn't it not? In the AC area, cold air will be there. That cold air is coming. It is blown off to the atmosphere. But before it moves off, before it is blown away, you have got a heat recovery wheel, which we call as a rotating wheel. This rotating wheel absorbs the chillness. So once it has absorbed the chillness, it tries to transfer the chillness to the incoming fresh air. See, the hot fresh air is coming from outside. Once it touches this particular heat recovery wheel, that hot air will become cold, and you find that green cold fresh air is supplied into the AC space. That is the advantage of this. Okay, now I am coming almost to the close of my presentation. Hope all of you are awake. Okay, now this is a very good thing. We are free cooling. Okay. What is this free cooling? Cooling is, see, when we say air conditioned environment, we say that we are going to maintain 24 degrees Celsius inside the AC space. But if the atmosphere is already cold, why do you want to run the AC system? You have to save energy. You have to save energy. So what we need to do now? we have to divert that outside air into the AC space. How that is done? Whenever the temperature is between 11 and 16 degrees Celsius, we will bring outside air and put it into the AC space. You see here. Yeah, when the temperature is between 16 and 20, between 16 and 20, we bring it and then directly put inside the AC space. When it is between 11 and 16, we mix it with the return air. Okay, so let us see. This is a typical diagram which explains that. This is your conditioned AC space. Okay, this is the fresh air plenum. The air is coming from the outside. This is the return plenum. Usually, what we do in the AC space, we take this air. The return air will come. It come to the plenum. Correct? No. From there, it will come to a set of damper boxes. It goes to the filter. Some amount of fresh air gets added, and then if it is required, you do the cooling. Then the fan sends the cold air into the conditioned space. When the temperature is very conducive, when the temperature is 16 to 20 degrees Celsius, see what happens. There are two dampers, damper D1 and damper D2. There are two dampers, no? Damper D1, damper D2. During the free cooling time, what happens? The fresh air is brought in, D1 is open. What happens D2? D2 is in off condition. Because D2 is in off condition, all the fresh air is coming, gets filtered and then is sent into the cold space, thereby we getting free cooling. Okay. So we have touched up many of these things now. I hope you have understood and session after some time. After my two colleagues, Mr. Anto Kumar and Mr. Karthik, both of them will be making their presentation. After that, we will have Q&A session. My request is, all of you have to write down your questions, otherwise you will all forget. Don't say any question. We are going to answer all your questions. Okay? My best wishes.
Sorry, I didn't realize that audio was not on so long. Anyway, I'll once again repeat what I said for the benefit of those who have not been able to. I think nobody would have listened anyway. So I said the last session, what we had on energy savings, Kalyana has already evaporated, exhausted, condensed and cooled you. Ultimately you got cooled now. So with that background, we all once again welcome you for this session on behalf of Bluestar. I am from the HR team. Now we will look at the career opportunities. I am not here to present on career opportunities across various industries or verticals. I am here to present and focus on HVAC related career opportunities. On the screen, we are viewing close to around 33 colleges have participated. I do not know the exact count now, if you can update me. I saw last was 33, 29, okay, some would have logged out. And we are seeing you on the screen. Maybe you will also be, we are also visible to you on the screen, but we are also able to see you on the screen. So that is it. Then coming to this, let us understand what are the career opportunities available in this limited and restricted to HVAC sector and domain and not to other domains. First of all, all of our graduating engineers. Couple of days back, I met a child studying 8th standard. I had asked the child, what is your focus? The child said, I would like to do aeronautical engineering. I thought something out of his mind is sharing something out. I said, do you want to become a pilot? Because normally when you say aeronautical, their focus is to immediate answer that it is going to be a pilot. Then he said, no, I am not going to be a pilot. I am going to do rockets. So that is the focus the child with 8th standard has. So we are all, you are all graduating engineers. What is the focus you have now? Are you focused? Some would have joined because they wanted engineering. So I am also an engineer. So many are engineers, I am also one of the engineers. Some would have joined, yeah, no, I have a goal, so I need to do engineering and then graduate myself. Some would have joined, okay, after completing engineering, I will get into a good job opportunity. Some would have joined, okay, after engineering anyway, getting married, somebody would ask, what have you studied? I have done engineering for getting marriage. So the goals, the objectives may differ. But whatever it may be, we need to have focus. I know there are a lot of giggles from the students there when I said getting married for after doing engine. That's fine, fantastic. What is the focus? What do we mean by focus first? We all heard about focus. We talk about focus. What is focus? Focus is saying yes to one and discipline to say no to 99. I repeat once again, focus is saying yes to one and discipline to say no to 99. So that is focus. So if you focus on one particular area, you would excel. Now coming back to this, you would see a picture there on the screen. It says choose a job you love and you will never have to work a day in your life. That means what? You need to have the passion, you need to have the drive. If you have the drive, like something, then you enjoy working with it. So that is what it means. Now getting into this, career prospects, as I told you earlier, it is limited to HVAC industry. So what is HVAC? HVAC is heating, ventilation, air conditioning. So this opportunities, whatever we discuss, is also limited only to engineering graduates and not to other postgrads. So to give an overview of this industry about HVAC, the total turnover for the last financial year was 13,750 crores. With respect to central plants and HVAC projects, Kalyan was elaborating on the ducting systems, the chillers, the AHUs. So those are the central plants and the HVAC projects, and the total business in this field of activity is close to 6,250 crores. Now the expected growth of this industry is 20% compounded annual growth rate. CAGR is compounded annual growth rate. The industry is nascent in the sense it has started well. Why did I say this is predominant and widely in metros? So there are tier 2 and tier 3 cities which are fast growing. So this will spread across to other cities as well. So that is why we have good amount of business in this industry. And especially when you compare this to China, in China, in India, it is only 1/10 of this business what we are doing now. So that is the opportunity what this industry has. That means when the industry is growing, we have employment opportunities, we have career prospects with this industry. Now opportunities, if I have to share a few of them, one is on the infrastructure. When the city is growing, when the infrastructure development is happening, the conditioning is an essential factor. Today you would not see a car without air conditioning system. So that has become a need. Likewise, a corporate or an office today, all offices are air conditioned. We cannot see an office except a few government offices still continue to remain with the old system. Then there is an increase in the commercial construction activities, and there is an up. MEP means mechanical, electrical and plumbing. So the question is, do you want to be part of this growth? If yes, we will proceed further. So the HVAC field has two basic verticals. One is on the non-ducted products and second is on the ducted products, which is called the projects. When coming to ducted, we have the splits and the window ACs, which is widely used in residentials. Then we have the cassette ACs. Then we have the mini splits. Then under ducted products, we have the central plants, the packaged air conditioners and the VRFs, which was explained to you by Kalyan what was VRF all about. Now coming to the job roles in HVAC, this is, as I told you earlier, this is limited only for engineering graduates. So there is a role for sales, planning or engineering. So there is a role for R&D, research and development. There is a role in manufacturing. There is a role in construction. There is a role in commissioning. So I will give you in brief what is expected of these roles up to planning, construction and commissioning engineering, and also deal on what kind of roles are available for research and development and what is all about manufacturing, what kind of roles are available in manufacturing. So let us see those areas what it is. Before getting into this, you are into engineering, so you will be studying various subjects or specializing in various field of activities in engineering related to HVAC. These are the related academic applications of knowledge what will be required for this field. One is related to thermodynamics. The whatever you study in engineering, these field of these lessons or these areas will be directly applicable to this kind of industry, which is the HVAC industry. One is the thermodynamics, second is thermal engineering, and third is fluid mechanics. And also need to understand in terms of the drawings, how to read a drawing, then the psychometry charts. Psychometry charts are used to calculate heat load. Machine drawings, then comes the AutoCAD. You can get specialized in AutoCAD, the Pro-E, then two drawings, 3D drawings, Creo 3D. So these are the areas with which you can get specialized yourself, update your knowledge if you want to partner with this kind of industry. Now coming into the job specific roles related to sales. Sales means this is not product selling. This is a kind of a techno-commercial role. This role is a techno-commercial role. That means we need to understand the market. As a product, you also need to understand the market and the business. Connect with consultants, PMCs, project consultants and architects. Then cost and tender submission. Costing means every sale or every tender is a unique tender, because it is not a product, off the shelf product, where you say that okay, these are the product, this is the feature, like a split air conditioner or a window AC. Here you need to visit the place, then understand the requirements, understand the need, where the place is located, understand the environment, and use your engineering skills and techniques to say that this is the type of product what you need. So that is the engineering expertise which is required for this role. That is why we call it a techno-commercial role. So while we know about technicals, so you also know about commercial aspects to this, so that you prepare the costing and the tender submission. Then comes the technical submittals, then review of contracts and the commercial aspects attached to these contracts, then conclude the contracts, then hand it. So the business starts from the time we prospect a business, or we understand the availability of the business in the market, and then we quote the tender and take the order from the customer. The second is on the engineering role. After making a sale, the role of engineering starts from there. That means validate the design intent. As I told you earlier, every project is unique and the design has to be made customized to that related project. So then only you will be able to make it. The second one is on the technical submittals and the approvals. Then again the coordination with HVAC consultants, service consultants and architects. Then preparation of design bought out quantity, DBO. It is also specific to that project, and also after making this DBOQ, the material requisition starts. So the role of engineer is to design, then coordinate, then prepare the tender document, then check for the materials what is required for that project. Then comes the role of construction. Construction means after engineering, then the role is to execute. Till now we were in the planning stage, now the execution starts at the site. Now here the HVAC drawing evaluation, whatever the engineering role has submitted a drawing, so that has to be evaluated. Then resources need to be planned in terms of manpower resources, in terms of material resources, in terms of mobilization of other materials, contracts, all these things to be planned. Then techno-commercial execution of project, then testing, commissioning and handing over, payment realization, preparation of CVR, cost variance report. See, we are not into the corporates are into a business. We have an objective to fulfill our objective here. So we will to understand whether are we overshooting the budget or within the cost. So that is why that CVR is prepared. Then comes the PMC coordination. Project, there is a project management consultant. So the role of this job is to coordinate with that consultant. Then comes the R&D. He has predominantly these kind of roles. I am not getting into too much of details into this. I can share you what kind of roles is available in this field. Product development, then system integration, either it could be mechanical or electronics, process engineering, Pro-E, virtual modeling, reliability, testing. So these are the roles available under R&D. Now coming to manufacturing, we have production engineers, quality engineers, PPC, production planning control engineers, then we have testing engineer, then we have maintenance engineer, then we have vendor development, then we have procurement engineer or supply chain engineers. Okay, so these are various roles which are available under the manufacturing in terms of undertaking a role in manufacturing. Now let us look at the after sales maintenance. After the project is completed, commissioning and handing over is done, then comes the maintenance part of it. Either it could be a maintenance under a warranty process, or it could be an annual maintenance contract post warranty. So here the roles available under this segment: service engineers, operation and maintenance engineer, then we have service marketing engineers, then we have revamp or retrofit engineers. The building would have been, the air conditioning fitted would have been very old. Say they want to revamp the whole thing. So that is a business again we get. So these are the type of businesses after sales maintenance has. I'm sorry. So what are the, so far we have seen the job roles available in this segment related to HVAC industry. Now let us understand what are the skill sets required. Are we ready for the job? While we have technical competence, is only technical competence enough to get you opportunity for employment, or you need a soft skill? If you ask me, soft skill is an essential factor without which you cannot get a job. So soft skills, if at all we have to talk about, communication, we all know that it is very important. Communication is like the bloodstream in our body. If there is no blood, what happens? We cannot survive. If we are not able to communicate, the survival is not there. So that is the importance of communication. So it is better that we equip ourselves in terms of expression, one, two, in terms of presenting ourselves. Many of them in academics, they would have scored some good fantastic percentages, some 90, 95 and all those things. But they may not be able to clear the interview part. You know why? The only reason is that they were not equipped with this skill, soft skill called communication. So it is equally important as you score percentages in your curriculum, communication is also equally important or high. So proactiveness, without this, getting into a job and sustaining that job is not easy. So unless otherwise, because today nobody is operating on a monopolist, everything is on competition. So unless we have an edge over competition, it is very difficult for sustenance. Imagine Bluestar is 7-decade-year-old company. The company is progressing year after year, and you know why? Because of this proactiveness. Without this, the company would have not sustained for 70 years in the field of air conditioning. And perseverance and passion, without this, again, the growth and the prospects are not there, and a good attitude is an important factor which one need to have. Without this, it's pretty difficult for anybody to sustain, even if you are a 90% or 99% scorer in your academics. Unless you have the right attitude, you may not be successful person. So right attitude, the communication and your technical skills will definitely get you a good career in the organization and a good career growth in the organization. That is what I could say. Now, having said that, there are a few associates where you can partner with to enhance your skills. This is related to all those of you who are interested to prospect with HVAC industry. Take note of this industry associations and get partnered with any of this of your choice, wherein you can get to this and update your knowledge in this field of activity. One is ISRE, which is Indian Society for Heating, Refrigeration and Air Conditioning. Second is ASHRAE, that is American Society for Heating, Refrigeration and Air Conditioning Engineers. Third one is CIBSE, that is Chartered Institution of Building Services Engineers. And fourth one is RSES, Refrigeration Services Engineers Society. You Google, you can find out the address or the contact numbers to these institutes. Now, in terms of the selection process, This is more so widely used across all corporates. We also follow this process of selection. Just to give an idea of how do we go about in selecting candidates. There is a technical and an aptitude evaluation. Then once it is shortlisted from the aptitude test, then you will be called for a group discussion. Then shortlist happens in the group, then followed by an interview, and then once you clear the interview, maybe there is a medical test and all those things. Then after that, the offer letter is issued. So this is the process predominantly and widely used by many corporates. This is what we also follow in Bluestar. Now, coming to the challenges, what we have from a campus to a corporate. One is the cultural integration. So what do we mean by cultural integration? What is culture? Culture is way of life. In corporate, is it different from a guy? If you ask me, yes, it is different. It is how you perceive and take it differently. So that is the way we look at it. Some of the examples, if you want me to share in terms of how different it can be from a corporate to a from a campus to a corporate, would be on the dress code. Now you are wearing a t-shirt, you come with a jean and all those things. It is not affordable to a corporate, even though we are into a Gen Z kind of a environment today. Today corporates have not migrated to that stage. It will come, it is far-fetched now. So for you guys, you need to follow the prescribes in terms of business hours, in terms of time. Today you have the option, first hour you attend, second hour, hey come on, it's boring, let me go to a movie, it's up to you, you bunk it and go. It is not possible in corporate to do so. So these are the cultural transformation one need to have between a campus and a corporate. Then casual to formal, which I had already taken it up along with the cultural integration. And the third aspect, what you see here is VUCA. Gentlemen, this is not vodka, this is VUCA. So what is VUCA? VUCA means volatile, uncertainty, then complexity and ambiguity. So we are into a business where it is a VUCA world. So we need to gear up to meet these VUCA. Are we ready? Are you ready for these VUCA challenges? I know that you will be ready for VUCA challenges. I am not for it. I am ready for a VUCA challenge. Are you ready? So the next aspect here to look at it is on the knowledge application challenges. While you have read various theories, how far you are able to recap those things and apply it to a job space, that is very important. So get to know the fundamentals very strongly, so that those application of fundamentals will fetch you a good amount of target implementation. So everything is driven by a goal or a target, so we need to meet and achieve those target. And expanding the comfort zone. As I told earlier, you feel bugged, you walk, you feel you want to go for a movie, you bunk and go for a movie. It's not possible, all these things. You'll have to compromise on all that if you have to enter into a corporate world. It is not that you need to be all the time working, but you are target driven. As long as you are able to plan and achieve your targets, life is yours, you can enjoy life. Then next is on the place of posting. Most of them prefer to stay in the hometown. Today, in today's context, it is absolutely impossible. I can share you one example. A year back or so, maybe a couple of years back, we went on a campus and hired diploma holders from South Tamil Nadu, that too from a kind of a rural pocket. The person knows only the regional language, that is Tamil. Beyond that, he knows to converse in English, so that is why we had selected him. He was posted in Delhi. Imagine a person with doing a diploma does not know language other than Tamil and conversation in English. Beyond that, he is not able to understand anything else. He took the job as a challenge. He went to Delhi. Today the guy speaks Hindi so fluently. Without even any hesitation, he took the job and left. So don't stick to hometowns. If you get out of it, know about different people, you come to know about different cultures, and your progression will be much higher. So there is a picture here which says that we seldom think of what we have, but always think of what we miss. So that applies to us all. Nobody is above this or below this. I can share you one short story if time permits. Yeah. Okay. One more. Okay, it's a short story. So she says it's a short story, we don't mind. Okay, this is a story about a supernatural beings. There is an old legend that at one time all men on earth were gods. Man so sinned and abused the divine. Brahma, the gods of gods, okay, decided to remove the god's head from men and hide it someplace where men can never find it again and abuse it. So one god said, let us dig a deep hole and bury that. Then Brahma said, no, man is very intelligent, he will find out all these things, so forget it. Then another god said, we will throw this in the deep ocean. Then gods, these people they will learn swimming very fast, they will dive and get hold of it. Then another god said, we will keep it in top of one tallest mountain. Then the Brahma said, no, people will climb the mountain and find it out. Then Brahma suggested one thing, okay, so let us hide it down in man itself. He will never think to look there. So that is what this is all about. Deep down inside all of us is the power to accomplish what we want to if we stop looking elsewhere. Everybody has their own potential. The only problem is that we do not realize what potential we have within us. We should tap ourselves and take out our potential. We will excel in this field of activity. So I have given a definition of what power is. P is equal to T into S into M to the power of N. And I am seeing on screen one college, JNTU. Can you tell me, JNTU, can you tell me what is this equal to T into S into M to the N? Can JNTU respond? Tap your inner potential and respond. JNTU? Welcome. Or switch screen to some other college, we will ask them on. JNTU, can you take chance? Nothing is right and wrong here. whatever is negative, we can understand. Then I will tell you what it means from my perspective. JNTU? Some other college? Some other college? Some other college? Only. Okay. Okay. I am not able to figure out. Let us give chance. Let us give chance. Somebody is raising their hands there. Okay, fine. Okay, forget it. P is power equal to T is time or man hours, the time we spend. S is the skill sets or the competencies, whatever we can consider it. And M to the power of N is morale to the power of N. Why is morale to the power of N? The more you increase, the more you multiply, the more you grow. So that is why M is to the power of N. Morale is the outcome of motivation. If you are self-motivated, you can do wonder. This simple formula states. Now, coming to the SWOT analysis. As I told you, we all of us are, we have our potential, we do not have our potential. So by doing this SWOT analysis, we can understand ourselves better. What are the strengths we have? What are the areas for improvement? And what are the opportunities and what are threats? So more to get into threats, we will look into the strengths, areas of opportunities and the areas for improvement. Some see things as they are and ask why. Others see things that never were and ask why not. So with this, are we competent enough? You please ask yourself, you are the best judge for yourself. So please ask yourself whether are you competent enough. So how can I develop my competency? You say yes, still you listen. If you say no also, still you listen. One is holistic grooming. You should be an all-rounder. If you need to be a competent person, you need to be an all-rounder. Set goals. Do we have a goal? If you do not have a goal, set a goal. Introspect and evaluate your skills through a SWOT analysis which I had shared with you. Then understand your area of interest. Develop your differentiating skill. Always have plan B, because whatever we plan, sometimes there are chances where we miss it. So have a plan B and keep going. Keep abreast of all developments that happen in your area of study. That is why we have suggested partner with any of so that you can update and upgrade your knowledge skills. The nature of business you wish to partner with. So you need to focus. That's what I said. You need to have focus. Have a positive attitude. We spoke about attitude. So be patient and have a good degree of tolerance. Today's generation problem is only this. We do not have tolerance and patience. We need to be tolerant. When the going gets tough, the tough gets going. Take care of your health, either it could be physical or mental health. Then invest in a hobby, have your own stress busters. We can't say that I don't need stress. Stress is part and parcel of life. You believe you can, and you are halfway there. So wish you all. With this, I share the dais with my colleague Karthik, who is from, who was like you earlier 3 years back, so he will share his experiences with you. This is on or off?
All right, good evening everyone. Thank you Mr. Aranto for the kind introduction, and I hope you've got a thorough insight on the technicalities of energy conservation and the career prospects in HVAC. Today I'm here to discuss with you on a subtle note, but before I start, as Mr. Aranto introduced, I graduated in 2011 as a BTech mechanical engineer from Vellore Institute of Technology, Vellore. And it's been 3 years now. I currently work with the Industrial Systems Group of Bluestar. And I decided, since I'm being a person who made this transition from campus to corporate, on how to bridge the skill gap between campus and corporate. Now, in the current economic scenario, there is a major gap in appropriately skilled labor across various industries, which is a significant and complex challenge to the growth and future of our country today. According to a survey from NASSCOM, nearly about 3 million people, 3 million graduates and postgraduates get inducted into the industry every year, but out of which only 25% of technical graduates and about 10 to 15% of other graduates are actually considered employable. So why is there such a big gap? We have the best of the institutes in the country. 40% of our population is in the prime age, 18 to 25 years of age, that is. And the literacy rate of our country also has been increasing gradually year by year. So why the gap? Well, to address that, I would like to start from a more of a corporate perspective. Now, research says that growth of an organization depends on two aspects. Number one is the skill, and number two is the attitude of one's human resource. Now, since we are addressing a gathering comprising of more of students, I would like to address on the skill aspect more, which comprises of technical skills. When it comes to skill, there is an eminent difference between knowledge and skill. Knowledge is somewhat, is all of you are very aware about, is something you learn, the concepts, the principles you learn from a book or a teacher or from a media or so on. But skill is totally different. Skill is how you imply or convert this knowledge into solving a real-time problem and coming out with a legitimate solution for that. Let me give an example. All of you at the end of 4 years are going to come out with fancy marks, GPAs, percentages, but all this reflects only your knowledge. Now, how much are you converting this knowledge into a skill is $1 million question. Since I'm a mechanical engineer, I would give an example of IC engines. We've been learning IC engines, there are various concepts involved in it, but how many people are actually given the opportunity or have taken the opportunity to dismantle an engine and see how individual parts are aligned and what individual parts does? So I too had to go through the hard way when I was inducted from campus to corporate. I still remember before I could even enter my workplace, I had to go through two months of intensive training, both 1 month of technical training and 1 month on behavioral skills, and only then in my workplace. That shows the onus which Bluestar has put in understanding this cause of a gap between a skill and the knowledge you learn. But today the industry scenario is very different. Very few companies are actually investing time and money on nourishing these skills out of individual students. The industry has become more short-term oriented and do not want to spend much time on long-term benefit because everyone has to survive in the current scenario. So what do we do and how do we bridge this gap between industry and campus? We can do that. Number one is by industry academia interaction. That is the reason why we and you are right here. I'm very appreciative of your universities, QEEE and CII to making this platform and having, I think, every weekly interaction between corporate and campus students to give you a perspective of how to nurture this knowledge into appropriate skill. Secondly, what we can do maybe in the system is well said, that introduce this as a part of a curriculum so that students actually get motivated since they get credits and ratings for attending such sessions. Second, what you can do is enter or enroll yourself into internships. All of you have got 4 years of summer break and equivalent number of winter breaks. Try to make use of at least 1 or 2 of these months into actually visiting the industry of your choice and try to understand how things work. Interact with the corporate and see how you can streamline your knowledge into the skill. Third, what you can do is an industry partnership, which I feel everybody should do it. All of you have final year projects. So make sure you do it with an industry. It's a win situation for you as well as the industry. A win-win for you because you get to work with the corporate, you have the experience, you gain some experience before you're enrolled into a company. At the same time, it also stands out on your resume. And on the corporate side, yes, they get fresh minds to address their issues and additional work sources, and it's a cheaper alternative for them as well. The fifth, what we can do is industries can act as consultancy services. Academic institutions can help industrial companies by providing consultancy services which are sought by small scale industries and entrepreneurs who have limited or no access to R&D and quality control facilities. So coming to the second part, behavioral skills, Mr. Anto has said. So this basically includes soft skills, emotional intelligence, team building, etiquettes, corporate etiquettes, email etiquettes, grooming, personal grooming, communication skills, body language. So these are not covered as part of any college curriculum as of now. And most of the time people learn this only once they are inducted into companies. But some of the institutions have some approach in hiring external HR consultants to promote this. But this you will definitely learn. It depends on person to person on how he picks up these soft skills, and it can be implemented once and when you enroll into it. Finally, it is very important for you to have the right balance of these behavioral and technical skills. For every day in a workplace is an examination. The employer is watching you all the time because your performance reflects on the organization, your boss, and even sometimes your co-workers. So it is very important for you to implement and take the best of these two skills to become a thorough professional and be a top of the game. Finally, I would like to quote by saying, everyone must start working hard to fulfill his or her needs from today itself. I repeat, everyone must start working hard to fulfill his or her needs from today itself. Otherwise, someday, someone will put you in work to fulfill his or her dreams. Thank you.
You will have the assignment. If you are audible. We are going to take the questions now. Please, the questions can be shot at any one of us. We have three of us. I have Mr. Anto on the left, okay, and then Mr. Karthik on my right. We are eagerly awaiting your questions. Which college is coming first?
Hello, please. Good evening to all of you. We're done with all the presentations for now, but then it'll be very nice if we have a few colleges asking questions and interacting, because we have all of them coming here only for this one session. This is the only opportunity you'll get to talk to them. And after listening to all the three presentations, you can have any, it could be related to career prospects in the industry, or what you need to do, how you need to prepare yourself. So this is the only opportunity you'll get to talk to them. So please ask questions, interact, and start hand raising. Or you can even type your questions on the chat and question tab.
You're going to ask some questions.
TPs, can you go ahead and ask your question, please?
Good evening, sir.
I think it's okay if your video is not there. You can go ahead and ask your question.
Hello.
Yeah, please proceed. We can hear you.
Hello. Is it audible? Hello.
We are hearing what you are saying. Please go ahead and ask your question.
Hello. Myself Umesh from Talavat Padmanabh
Yes,
College
go
of
ahead.
Engineering. Hello.
Very good. Yes, Kubresh, go ahead.
Yes. So, sir, I wanted to know about the latest trend which are happening in the case of refrigeration and air conditioning, where we can save more and more energy and utilize it properly, so that we can utilize it properly in case of refrigeration and air conditioning. Because currently we are facing like whatever we learn in refrigeration and air conditioning and we teach, there we generally use basic things only. But what we can tell students exactly, so that they'll be aware about all these things. Hello.
Okay. I will give you the answer. The latest energy conservation practices in the field of air conditioning, I had actually brought out about 10 or 11 points in the presentation. If you had gone sat through the presentation, you would have captured some of those thoughts. See, one is when you take up building design. In the building design, you have to ensure that we don't have much of glass. You're going to provide much of glazing on the walls instead of you're going to have more of glazing. Then you need to protect heat ingress. We need to prevent the heat ingress. That's one. Second one is, the second one is, once the heat has come in, you need to effectively remove it. Okay, a building, the maximum amount of energy is consumed by an AC system basically to cool. Okay, to cool only a lot of energy is being spent. Okay, our objective is what? Prevent the heat ingress into the building. First one. attack the cause. And the second one is having brought it in, how effort. Okay, so one way of doing it is going to a spots where actually the load is coming and give appropriate cooling in those locations. This is one aspect of it. And the second one is give systems which will have some type of, which can hold some amount of cooling in them, like chiller plants, okay, something like VRF system. You will have that benefit in terms of giving the cooling for longer time. Okay, of course, when you have systems running, always incur energy. You will have to spend on energy. Our objective should be to run those systems in an energy efficient manner. So there are pumps which have to be used, which are energy efficient. The motor which drive those compressors and the air handling units, they need to be, selected in such a manner they are energy efficient. These are the ways we have to do this. So we have got VRF system to cool the building. We have got, we have got chilled water systems. Actually speaking, the latest technology, I actually was talking to you people regarding the magnetic compressors. Those compressors which have got magnetic shafts. Using those particular compressors, fitted chillers, the amount of energy that you need to spend to produce 1 ton of cooling is only 0.35 kW. 1 ton, you will get 1 ton of cooling, but the amount of energy you will consume is only 0.35 watts. Can you believe? 1 ton is, 3,520 watts. To get that amount of cooling, you hardly will be spending 350 watts. Where is the EER now? My dear, you work it out now. 3,520 divided by 350, you are having a 10 EER. Okay, so these are all always possible. We have to intelligently select the system. Very good.
Yes.
I hope I have answered this question.
Yes, thank you, sir. And my second.
Very good. Very good.
Good evening, sir. You said that we will be using the chilled water setup for cooling the air conditioner space, right? Yeah, can you hear me, sir?
Correct.
Yeah. Okay. Do you have any other
I'm hearing
economical
you.
ways to cool
I'm hearing
the?
you.
What? Yeah. Yes. Do we have any economical ways to cool the air conditioner space other than this large setup and all?
Yes. We
Yeah,
have. I did make a presentation on VRF system. No. When we have VRF system, basically it is called what? Variable refrigerant flow system. In the variable refrigerant flow system, the cooling is produced to the extent that is required. When I made the presentation, I also mentioned to you, evaporating refrigerant is producing the cooling. That means that quantum of refrigerant we will evaporate near those respective locations. Okay, suppose if you you have a small cabin, and that okay, the quantum of refrigerant that is required to cool that space alone, that refrigerant will flow there. That is the advantage of VRF system. Suppose you have a big office, general office is requiring 10 tons of cooling required. Okay, 10 tons of cooling is required. So you will have to send 10 kg of refrigerant to evaporate every minute to that place. So that amount of quantity of refrigerant only will go there. So you get the advantage of going for smaller system, at the same time cooling being delivered to meet exactly the demand of that particular space. That is the advantage of VRF system. People of them are today slowly migrating from chilled water system to VRF system across the world. So you also can look forward to having such systems also in your college, in your offices, all those things. Yeah.
Yeah, it's okay, sir. But can we use the principles of magnetic refrigeration in this case?
Can you please repeat?
When we use the principle of magnetic refrigeration for cooling the environment, in this
Oh yes, magnetic refrigeration. Yes. See, there are a lot of papers which have been submitted on this magnetic refrigeration. Okay, exploited science. There are enough papers which are talking about this magnetic refrigeration, you know, and if you are able to do it, it will be lovely. Okay, my recommendation to all you young people is that you should look forward to working on this and make it you know, a financially viable alternative as soon as possible. Yeah, it's nice, very nice, good. There's a good opportunity available over there. Indeed, you are right. Yeah, you are right. Yeah.
thank you for your answer.
Good evening, sir. I have some technical questions. What reference operating condition is calculated? At what reference operating condition the EER is calculated?
Can you be a little louder? Can we louder, please?
At what reference operating conditions the EER is calculated? Do you have any reference conditions for calculating the EER?
Okay, I will address this question first, which is there appearing on the screen for me. Why EER, energy efficiency ratio, is kept very low in India compared to other foreign countries, where the EER is almost 4 times, even when we have a shortage of power. Okay, this is a good observation. The government of India, Ministry of Power, they have one agency called Bureau of Energy Efficiency. They have continuously, you know, bringing out bulletins and giving us guidance in terms of how to improve the energy efficiency. They give us targets. You might remember the latest the table which is appearing 2.7 is single 1-star rating, which is really pretty good, and we have been they have been rising the year. Now I'm sure we will catch up in the days to come. We will very soon match or, you know, overtake them pretty soon. It's only a question of time. We will be there very soon. Their, you know, their numbers, we will be going over their numbers pretty soon.
Same, or is there any difference? Are the same, or is there any difference?
Can you please repeat?
What is the difference between EER and COP? What is the difference between EER and COP?
Okay, as of we have taken it here, it's the same. COP and EER, actually we have taken the same here. Normally when we say EER, you know, when we take it onto the basics, we say EER is equal to the cooling that is produced, you know, in BTU per hour, you know, divided by the power consumed in, you know, watts. But then what we have done in this EER is the definition given to us from the efficiency. What they have done is they kept both the units same. The cooling is delivered in watts, and the energy consumed, you know, cooling delivered is in watts, energy consumed is also in watts. So that's why watt by watt, this is the EER we are following presently, and on this basis, the star rating of our air conditioners have been given. Okay. COP is the coefficient of performance. Coefficient of performance and our EER is almost the same when it comes to star rating of air conditioners. Yeah.
Good evening, sir. This is Umesh again from Talla Padmavati College of Engineering. So actually, you are talking about the different opportunities which are available in Bluestar for it's like placement scenario. So like our college, which is and currently grows, how we can expect opportunities in your company, and if opportunities are there, how to approach you? Yes, sir.
Okay, I will give you this. This question will be answered by my colleague, Mr. Anto Kumar. Yeah, I'll give this microphone to him.
Okay. As I understand, you are wanting to know how do I get into Bluestar? The answer is very simple. First of all, we need to have a need for hiring. 1. 2, is on need-based hiring we do. Every year we go to campus and we shortlist institutes. Our first plan is to shortlist institutes. We have a criteria for shortlisting of institutes. So if your institutes fall within that criteria, then we prospect, we touch with your placement officer and then prospect further on this.
Thank you, sir. So what are those criteria, sir, exactly on the basis of which you actually choose the colleges? Can you elaborate, sir?
Yes, sure, I can. It is based on the ranking. We go by the Outlook survey. If your institutes fall within the top 50 rankings as per the Outlook survey, then you become one of the shortlist. That institute becomes one of the shortlist. And probably if your institute stands within this ranking, your placement officer can get in touch with us.
Okay, sir. Thank you. Thank you for the information.
It's been wonderful interacting with all you young people, and we appreciate the patience and the energy and effort you all had to sit through this 2.5 hours of interaction with all of you. On behalf of Bluestar, I take this opportunity to wish you the very best in your lives. All of you, we pray and we wish that all of you should come up very well in your life. You all should become good engineers. We want all of you to become good role models for others to emulate. For us, from Bluestar Limited, we have many of these interaction programs like CII, many industries associations. We have such interacting programs, so that we can help people mold the get ready for the future. Okay, so best wishes to all of you. Kindly take care.